Hello everyone, this is M. Vasuki from the Department of Computer Science and Engineering in Alamein Engineering College. Here I am going to discuss about the topic phases of compiler design. First of all, let's see what is compiler. A compiler is a software program. It actually translates human readable source code which is written in high level languages like C, C++, Java, and it will be converted into the level languages which is basically target code, which will be machine understanding code. It will be easy for computers to understand and execute. This is compiler. There are six phases of compiler design. These six phases of compiler design, it comprises of the sequence of each phases input from its previous stage, and it has its own representation of source program, and it will be feed to the output of the next phase of the compiler. First phase it is lexical analysis, second syntax analysis, third is semantic analysis, intermediate code generation, and then code optimization and code generation. In the first four phases, it will be considered as a front end of the phase, and last two phases back end phase. These first two end phases generally we can call it as an analysis phase, and the second backend phase we can also call it as a synthesis phase. In between these two phases, intermediate code representation is taking place. This intermediate code representation comes from the analysis phase, and it will be taken into the input in the synthesis phase, and it will give the machine code. First we'll see the lexical analysis phase. What is lexical analysis phase? It is the first phases of compiler design. In this first phase of scanner works as a text scanner. This means we'll give the programming language, high level languages. It will scan each and every lines of the program, and it will be converted into the tokens, and it will be these tokens will be we can call it as lexemes. It is meaningful lexemes, and this lexical analyzer represents these lexemes in form of token as is the syntax, token name, and attribute values. Like this we can represent the lexemes. Syntax analysis phase, this is the second phase of the compiler design, and these phase tokens produced by the lexical analysis as an input, and it generates parse tree. In this phase, tokens are checked against the source code grammar. That is, the parser check if the expression made by the token is syntactically correct. If in case any syntax error means, this phase will check. Then semantic analysis, this is third phase of the phases of compiler, and this semantic analysis check whether the parse tree constructed follows the rules of the language. It means if we declare any variable, it means int a equal to 0.4. Now you can say 0.4 is a float value. So here the data types is not mismatched, so we can say here this is semantic error, and these semantic errors can be analyzed in this semantic analysis phase. That is here explained. For example, assignment of values between the compatible data types and adding strings into an integer. Also, semantic analyzer keep track of the identifiers, their types and expressions, whether identifiers are declared before use or not, etc. This semantic analyzer produces an annotated syntax tree as an output. And intermediate code generation. After the semantic analysis, the compiler generates the intermediate code of the source code for the target machine. It represents the program for some abstract machine. It is in between the high level language and the machine language. This intermediate code should be arranged in such a way that it makes it easier to translate it into the target machine code. And then code optimization. The next phase after the intermediate code generation, we are taking code optimization phase. This optimization is assumed as something that remove unnecessary code lines like extra lines, empty lines, like any codes in between are arranged in the sequence of statements in order to speed up the program without wasting the resources like CPU memory and wastage of memories. Next, code generation is the last phases of compiler. In this phase, code generation generator takes the optimized representation of the intermediate code and it will be mapped into the target machine language. The code generator translate the intermediate code into the sequence of relocatable machine code. This sequence of instruction of machine code performs the task as the intermediate code would do. And the last one is symbol table. So far we discussed about the 6 phases of compiler design, and this is how this symbol table is used to store all the datas in a memory. It is a data structure that is maintained throughout all phases of compiler. All the identifier names along with their types are stored here. This symbol table, it will be make it easier for the compiler to quick search the identifier record and we can retrieve whenever we need it. This symbol table is also used for the scope management. Thank you.